1. I got 7.
And 5.
And 5.
Is it on?
Any other 3? Alright, let's do those 3. Don't break the pen first. I'll take it. Alright, back to focus, so you're going to go back to your seat. Number 1, are the following equations parallel, perpendicular, or neither? If I'm looking at the slopes, I see that these are flipped. One is negative, one is positive, so that is perpendicular. Questions on that one? Number 3, solve the inequality. This is one of your compound inequalities, so we have to solve whatever's on the inside, get it out by subtracting 1. And then dividing everything by this negative 5. Because we're dividing by a negative, all the signs are going to change directions. But with our compound inequalities, these always have to be less than or equal to, and it has to be least to greatest, so we have to take the whole thing and flip it. So negative 4 is less than or equal to x, which is less than negative 2, would be your final answer. Questions on that one? And then number 5. Graph the following. We have to solve this first. Get rid of 2x by subtracting it. And then divide everything by 3. Then we could graph it once it's in slope-intercept form, starting at the y-intercept, positive 2. Slope of negative 2 over 3, so go up 2 to the left 3 as many times as possible. Down 2 to the right 3 as many times as possible. And then connect those points and make a line. Draw arrows at the ends. Questions on that one? Again, if you didn't grab a calculator, go grab that. We need that for today. And then I need cell phones put up.
You want to see my calculator? Look. So cute, isn't it? It's just like the old one with the back.
Looks like a calculator.
You love my calculator.
Yes, I love your calculator. It should be pink. You guys can close your computers also. Pink.
I said I guess I could paint
Pink.
I'm not going to paint my calculator.
What? Diego.
If any of them color,
Pink.
I don't like pink.
Alright. Everyone should have these notes in front of them. We're doing the third objective of quadratics, which is identifying solutions or roots from a graph. Some of this will be review from what we were just talking about, graphing, but then also we're going to talk about solutions. So write this down. So we've mentioned these words before, but when we were dealing with linear lines. So now we're going to be talking about roots or solutions, the point at which the parabola, the U shape, the quadratic intersects or crosses or touches the x-axis. All of these words can be interchanged, but most of the time when you hear the word roots, you're talking about quadratics. But they can also be known as zero solutions and x-intercepts. And then draw these rough sketches. They don't have to be perfect. Two solutions is when the parabola, the quadratic, crosses the x-axis twice. One solution is if it touches the x-axis just once, and that could face up or down for both of those. No solution is if it doesn't cross the x-axis at all, and again, that could face up or down. So we're going to do the 3 examples on this page. Probably not all before lunch, but we're going to graph them, find the solutions. I'm going to show you how to find them from the graph and also on your calculator. So go ahead and put number 1 into your y equals. So number 1, put in x squared plus 4x minus y. And these tables are a little bit longer than the tables we had before. Those were 5. I think these are 7. But go into second graph, to get your table. Same as before, find where your y values repeat and find the middle. -4, -5. Isn't the middle, is that what you said?
No.
Okay.
9.
-2, -9. That would be the middle, yep. And then you can fill out the rest. I'm going to fill this up first. -3, -4, -5, -1, and then -8, -5, 0.
Awkward. How can you find out what's the middle?
So when I'm looking at these, so let's say I was back where I started. I see that these numbers keep getting bigger, so it's not going to be that way. So if I start to go up, I'm going to look until I see 2 of the same numbers. And then when I see that, I'm going to do that until the numbers don't repeat anymore. Graph all of those points. Your points should be even on both sides, so it shouldn't be lopsided. You shouldn't have like 10 points on this side and like 3 points on this side. So then as we're looking at this, how many solutions does this have? 2. It crosses the x-axis twice. So we're going to write these just as we did when we were solving the quadratics by taking the square root using the curly brackets. So x equals curly brackets. What are the 2 solutions? -5 and +1. So you can see that from a couple different ways. In our table, we have that here. But also, you could look at the points, the ordered pairs as well. So you're going to write that as -5, 1, least to greatest. Now, I'm going to show you how you would find that in your calculator really quickly. So we had that already. If you go into graph, so just hit graph, not second graph. Most of the time, if it crosses and it looks like it's at a point, that's usually what the point is. You could double check the table to make sure, is this actually at -5 and 1? But let's say it was a little off, so we know what it actually is. But if it was off or we couldn't tell where it was, we're going to go into calculate, second trace. Which of these do we think we're going to be using? We don't have two lines that cross. That would be intersect. 0. We're going to use the 0. That's going to be our root, our solution. So going to number 2. The issue is you can only do this one at a time. So if there are two solutions, you can only do this one at a time. So let's say I'm trying to find this one. The left bound is something to the left of this. So pick a number that would be left of this. -8, sure. So I can type in -8, hit enter. A line will appear, or mine is a line, yours might just be the cursor. Then I want to pick something that's to the right of this, but that doesn't go past the other one. So somewhere in here, -1, sure, that would work. Type in -1, hit enter. Then it says guess. You don't want to guess because that would be you putting it where you think it is. You just let the calculator do the work, hit enter again, and it will tell you what this is. Now, right now, this is a bunch of zeros. This would be at -5. So the 0 is -5, and that's a good way to check yourself. But if you have the equation, if you don't have the equation, you have to graph it or look at the graph. We'll do the other one just in case you missed any of that. So go back to second trace. Go back to 0. And then for this one, I need something to the left of this, but that doesn't go past -5. Sure. -1, type that in, hit enter. And then something to the right of this. Sure. 5, hit enter. Now it's looking between these two places, hit enter again, and it'll tell you what that is. So this time it actually said 0, the other one should have said 0, the calculator does weird things. But that's a good way to double check yourself in the calculator. Questions on that? Go ahead and put number 2 in and start finding those points. So there would be really no work to show unless, because I haven't shown you how to do it algebraically yet. So this would be, you have to use the calculator. And then go into the table and find where your y values repeat. Find the middle.
-2, -9.
The 9 repeats, but 1, 0 would be the middle. I went too far. And then you can put all those points in your table. And graph those points. That one has how many solutions? 1. And where is that? So it's at 1. So that would just be x equals curly brackets 1. That's it. You wouldn't put more than what you have. Time-wise, we'll do the last one when we get back to lunch. Look at the table and find the points that would be in the middle. Find the order pair that would be in the middle.
1, -2.
So go ahead and fill out your table. The negative 11 is going to be off the graph, so you can graph that or not. That's up to you. How many solutions does this one have?
0.
0. It does not cross the x-axis at all. Looking at this to make sure I get this right. You really like that? Can you write none of these? You can put no solution. But because we're trying to get used to writing it in this set, you should also have an x equals in there. Look at questions 4, 5, and 6. Do we want to see you go over any of those? 4, 5, 5. Okay.
You said
Alright, so let's do number 5 and then we'll move on to the last thing we have to talk about with this, and then you'll practice a couple of these. So go ahead and put number 5 into your calculator. And find the middle of those points when you're looking at the table.
0.9.
Go ahead and fill out that table with those points. How many solutions will we have there? 2. And what are those 2 solutions? -3 and 3. So you could write that one of 2 ways. Either with your curly brackets, -3, 3, or as we were doing it with the square roots, plus or minus 3. Either or. Do we have any questions in general about how we find the number of solutions, how we find the solutions on the graph using the calculator or not? So make sure you have this written down and then go on to the next page where it says writing quadratic equations by identifying the roots. Alright, we'll do a couple of these. So this one is basically doing what we were just doing, but now we have a graph. So let's find the solutions. There are 2 of them. What are they? -5 and positive 3 plus 2. So that was -4. I'm just going to write that off to the side. When we write this with roots, this kind of goes back to when we were graphing from vertex form. When we write this in the root format, we write the opposite thing. So instead of -4, we're going to put x plus 4, instead of positive 2, we're going to put x minus 2. The reason for that, if I were to take this, set it equal to 0, and solve, I would get the actual answer. So we have to do the opposite so that we can eventually get the right answer. Same thing with this one. But we want to rewrite this so that it's back in standard form. So we're going to FOIL distribute x times x. X times negative 2. 4 times x. And 4 times negative 2. And then combine your like terms to figure out what the actual equation is. Which means if I graph this and I graph this, they should look the same. So I'm going to graph this one just so we see that. And then we'll do another one. This part is really just extra. Really, you need to be able to do this part. So if I'm looking at this, I see that it has a 0 at 2 and a 0 at negative 4, which is what my original graph did. And if I look even further, there's a y-intercept at negative 8, which this one also does the same thing. So I know those would overlap. Questions on that before we do another one? What are the intercepts of number 2? For this one. Not a 5. Where's it up?
7 and 8.
7 and 8. So then if those are both positive, how would we write that in this format? X minus 7, x minus 8. Then we can go ahead and distribute to get the actual standard form. X squared minus 8x minus 7x plus 56. What is that final equation? X squared minus 15x plus 56. Yep.
How do you get 56?
I multiplied this one.
Oh.
So I didn't show that in the first one, but we're multiplying those two together. Yes. I'll write the opposite side in 2 seconds. So I try to color code that percent. First is foil is first, the first 2, and then outer, the outsides, and then inner, the insides, and then last, the last 2 numbers. Do we want to see 3 or 4 before I let you guys practice? You want to see it, you can say something. 3. You need to go back up. Okay. What are the roots for number 3?
Negative 8. Negative 3.
Negative 8 and negative 3. How would we write that in the parentheses?
X plus 8.
X plus 8 and
X plus 3.
yes. Go ahead and distribute that. And combine your like terms. What is that final equation?
Equals 2 squared.
X
X
squared.
squared plus 11x squared.
Edwin, by the way. Alright, I'm gonna have you guys do 2 problems. Raise your hand when you finish, I'll check them, and then you can be working on other practice. So number 4 is gonna be one of them. And then from the previous page, I want you to try number 6. So number 6 from the previous page and number 4. Do both of those. Raise your hand when you finish them. And then I'll check them. 6 on this page, 4